Hello everyone. Okay, today we are going to talk about two things. One is what do we mean by reading and writing as far as Arduino goes, and secondly, we'll talk about digital pins and analog pins and what does reading and writing over there means and what values can be read or written. Okay, first things first. Let's talk about reading and writing. What does reading and writing mean? So when I write read anywhere, read actually means taking data from sensors and data is going towards Arduinos. That means data is going to the Arduino. And examples of sensors are PIR sensor, DHT sensors, tilt sensor. All the sensors, these give information to the Arduino. So when the information is coming from any sensor or from any device and it is going towards the Arduino, we say that Arduino is reading data. We say Arduino is reading data. So that is what reading is means. What do we mean by write here? Write means taking data from Arduino and going to actuators. Actuators actually means things which are actually working like servo motors and DC motors and LEDs and speakers, buzzers, everything that uh, actually is the output from the device. So when the data is coming from the Arduino, we mean I'm doing a write operation. Okay. When the data is going to Arduino, that means I'm doing a read operation. Call that as a read operation. So we here say Arduino is writing data. All right. So this should be very clear. What we mean by read and write. Okay. Secondly, reading and writing can be both digital and analog. When we talk about digital actually means digital is only two possible states, 0 or 1, on or off, high or low. So only two possible states, that is digital. That is how computers work. But analog actually means um, multiple information, multiple or a range of data. So that means the data is not uh, only a 0 or a 1. In case of Arduinos, it is either 0 to 255 or it is 0 to 1023. So that means there are many possible values between a minimum and a maximum. So this is what we when what we call an analog. Now, digital data basically would mean using something like a switch. A switch is always on or off. Okay, it will be either on or off. What about uh, analog devices means? For example, I have a temperature sensor. Now, temperature sensor will give you information, and that information is not just going to be on or off. It is going to be a range of temperatures, right? If it is a humidity sensor, it will be a range of humidity. Okay. And if I talk about an output device, a motor is getting a range of speeds, a range of direction, a range of angles. A device like LED, a range of brightness. In case of speakers, a range of possible sounds. Okay, so in all those devices basically would mean analog. The next part that we need to do is talking about digital and analog pins. We know that we have digital pins, and digital pins are actually from 0, they are numbered from 0 to 30. And some of them are PWM pins also. And PWM pins are actually 3, 5, 6, and 9, and 10, and 11. So these are PWM pins, others are not. What can we do with digital pins? With all the 0 to 13, with all the 0 to 13, we can read and write digital data. So what do we mean by reading and writing digital data? It actually means uh, reading and writing on or off, 0 or 1. Okay? So that means we'll say low or high. How do we read information? When I am reading information from a sensor or any device, that information has to be stored somewhere. That has to be stored somewhere. So I'll use a variable called var maybe is equal to, and I want to read digital information. So I'll say digital read in bracket whatever is the pin number from which I'm going to read. Wherever the sensor is connected. Okay. So here the sensor is connected to pin 7. Alright. So that means whatever the sensor, it doesn't matter what sensor it is, and it has to be a digital sensor, right? For example, a switch. A switch will be on or off. So digital read is going to give you an information. So var is going to get information only a low or high. That means it will get a 0 or a 1. What about Hanji? This part was reading data. What about writing data? Writing digital data. When I want to write digital data, that means I want to pass this information, whatever I've received from a sensor, I want to pass it to an actuator. Maybe the motor should switch on or the LED should switch on. Then how do we do that? We do a digital write now. So we say digital write, and where do I want to write? Suppose the pin number is 10. I want to write on pin number 10. I want to write the value of var. So this is how we write. Okay, so I'm not storing any information here because this is not returning anything. This is actually doing something. So basically something is connected to pin number 10. Let's connect something to pin number 10. So an actuator, for example, an LED is connected to pin number 10. Okay. So what is going to happen if this digital read had actually sensed a high, the var will have a value of high, and this digital write is going to write high onto pin number 10. That is, LED is going to switch on. If I want to give a fixed value to an LED, so I could have just written high. That means this will always switch the LED on. Okay, next part, writing analog data. An analog information which is taken maybe from an analog pin, if it is supposed to be written onto an actuator, maybe a motor, maybe an LED also. So how do we do that? We say analogWrite, analogWrite in brackets, which pin number? So we uh, take any pin which is a PWM pin, for example 9 is a PWM pin, and we write the value. So whatever value you want to write. Now please remember the values here are going to be are going to be from 0 to 255. Okay, so that means if I say analog write 9 comma 127, which is half of 255, our LED is going to be half lit. So that means it will be half bright. It's not going to be full bright. If this is an LED, this will be full bright, and if this had been a low, it would be it would be switched off. But here it is going to be half bright. So I can change the brightness of an LED by using an analogWrite. So now this was all about digital pins. On digital pins, I can read and write digital data. I can read digital data. I can write digital data, and I can write analog data. What about analog pins? Analog pins are basically used to read analog data. So analog data is going to be read from here. For example, so let's say int var is equal to analog read in brackets pin number. Pin number is, for example, A0. That's it. So if I write this, what is going to happen? Any device which is connected to A0 is going to give me information, and that information is going to be in the range of 0 to 1023. This you need to remember. Okay, and var will have a possible values of 0 to 1023. Okay. Okay, now we know how to read information and how to write information. Let's take some examples. I want to read from an analog device and I want to write to a digital device. Okay, write to an analog device. I'll tell you how to do the other also. I want to read from analog device and write to another analog device. How do I do that? So what will I use to read? What pin will I use to read? I will use a pin, an analog pin. For example, I will use A0 to A5 to read. What will I use to write? I will use any PWM pin. I will use any PWM pin. Okay. So I will give a command something like int var is equal to analog read A0. I am reading from pin A0 and I want to write onto, so it is an analog write. What do I want to write? Where do I want to write? I want to write on pin number 3, which is a PWM pin, and I want to write the value of var. So this is possible. This is the probable thing that we need to do. Okay. For example, I'm reading from an analog device. For example, a potentiometer, and I want to write on to an LED. Okay. So this is an example. Second example. The next example would be read from analog device and write to a digital device. For example, I'm reading again from a potentiometer and I'm writing again onto an LED, but I'm just switching it on or off. Okay, so can we do this? Yes, a potentiometer could be used to switch an LED on off also. So that means if it is maybe less than half of the potentiometer, then it is off, and if it is more than half, it is going to be on. Okay, so let's do this. Where am I going to read the information? The read is going to be again onto an analog pin A0 to A5. The write is going to be on any digital pin, so that means I can use 0 to 13 all the pins. How am I going to do this? I'll take int var is equal to analog read in brackets A0. Maybe A0 is connected to the potentiometer. Now I cannot do this directly. That means if it is, how do I convert a digital thing to an analog thing? Sorry, or an analog to a digital thing. So how is it possible? So what we'll do is, in fact, the input is going to be coming from 0 to 1023. So what we'll say is, if it is less than 512, then this the our LED is going to be off, and if it is not, then it is going to be on. How are we going to do this? So we'll say if var is less than 512, so what do? We switch it on. We say digital write in bracket. Suppose our LED is connected to pin number 7, so I'll say 7 comma high, so I will switch it on, else I will switch it off. Okay, so switching off would actually require us to give a low here. So yes, we have now successfully used a potentiometer to switch on or off uh, an LED.